All right, good morning and welcome to GCC. I don't know if it's a welcome back or just a welcome for the first time, but welcome. Welcome to Math 096, Intermediate Algebra. My name is Ian, and we have a lot of handouts as you see. So we're not going to look at all the handouts today. I'm more interested in having you guys do math than to talk policies with you. We'll start here at the top of the big packet. You can see that they are, the packet is hole punched, so if you have a 3-ring binder or can get a 3-ring binder, that will make your life much better in terms of being organized for this class. So we'll start up here with the daily summary, and Kayla, could you read that for us? Thank you. Ramses, number 1. Okay, so that's going to be the basic layout of our course. Each day we'll just do a little bit of math together, and then the bulk of the class will be you guys working with your neighbors in your groups, and I will walk around and help out as I can. One of my fundamental teaching philosophies is that it's far more important to me that you do math than that you watch math. So my part up here is going to be very, very short each class. But we do have a little bit of logistical stuff to talk about, so let's jump into this other thing, which you don't have a copy of. So I'll just project real quick here. But here's our math flow chart, and I will say that at the moment, you guys are right here in Math 096, and that's great. I'm happy to be working with you this semester. But I want to be clear that this class right here does not satisfy the math requirement for any degree here at GCC. So does it satisfy a math requirement? No, it does not. But I will put yeses next to ones that do. Maybe after this semester you take a stats class, or you take college algebra, which leads all along the calculus track. But there's another class up here that's at the same level, so to speak, as the class that you're in right now that does get credit for the general liberal arts math requirement. And so if your goal in taking this course is simply to get a math credit for your degree, then it might not be the best place for you to be, because this one doesn't count. You got to do one more after this. But most and perhaps all of you could take Math 117 this semester instead of this class, which would satisfy the degree requirements for our liberal arts degrees. Any questions on that? So if you know you're in the right place, super. If you know you're in the wrong place, or you're not sure whether or not this is the right place, talk to me right after class and we'll figure out where to go, okay? But if you're going to make a change, obviously the sooner the better. Okay, so that is good there. The other thing I wanted to talk about really quickly is the syllabus, which you do have a copy of. So go ahead and grab that syllabus. And again, we're not going to talk all the policies together. You'll read this as part of your homework tonight. But there is an important change that I need to make. Right over here, this studio hours on Tuesday from 11:30 to 12:30. Everybody see that? Cross it off. I have changed when that is happening. So we're crossing off the studio time on Tuesday, and we are putting it on Friday, 11:45 to 12:45. So put it there in that same column on Friday, 11:45 to 12:45. Everybody have the change? Okay, so this is a good time to talk about the studio. So the math studio is that room right behind all the glass walls, just on the other side of the hallway. Is there anyone who has experience here in the math studio and can share with your neighbors what it is? Raise your hand if you've been in the math studio before. Fantastic. Any of the people with your hands up, share what the math studio is. Who is they that helps you? Math teachers, right? So I'll give you a schedule for when the math studio is covered. It's being printed as we speak, but oftentimes you'll find a math teacher over there in the other room, and you can go and just sit and do your homework and raise one of these flags if you have any questions, okay? And so I will be there just that 1 hour a week, but there are lots of other people that will be there throughout the week. Okay, so I don't want to talk any more about the syllabus. What I do want to do is come back here and start doing some math. Jumping in at number 2, we're going to Irene. Could you read 2? Go ahead, 20 seconds. We're writing down 4 names. You will forget them if you don't write them. Ask again. No shame in having forgotten these names. Write down 4 names. Lucas and Alice. Everybody have 4 names written? Fantastic. Okay. All right, 4 names are written there. Wonderful. All right, so now we're going to start the demo, which is the math piece that I essentially lead up here. We'll begin with number 3. Jeremy, could you read 3? Keep going. Okay, so I've got this table. The first column is X. There's some numbers that I've already chosen for X, but essentially you could pick any number. And we're going to fill in the Y column together right now. So in the first row, X was -5, and we're just going to be using that equation right there. Y is always equal to the X plus 4. So in that first row, the X becomes -5 plus 4, which is -1. So far, so good. And then we'll fill in the next few rows. So in this case, again, it's normally Y equals X plus 4, but what am I putting for X here? -2, and then plus the 4. Everyone see it? In that second row, I chose -2 for X, and we add those and we get 2. And then we got 2 more to do. Okay, somebody we haven't heard from yet. Instead of Y equals X plus 4 in the third row. Thank you. And then again, somebody we haven't heard from yet, last row. Y equals 3 plus 4, which is equal to 7. And math folks love writing ordered pairs when they can, so we're going to list these guys as ordered pairs. First one comes from X equals -5, and the calculation showed that Y was -1, and we know that when we list ordered pair, X and then Y in that order, right? So that's the -5, -1. Next one is -2, comma 2, 0, 4, 3, 7. Questions on those? Okay, what you're going to do right now individually and then check with your neighbors is parts B, C, and D, which involves plotting some points, drawing a straight line, and then answering a question about that line. We'll come back together in just a minute. Okay, so hopefully you've checked your answers with your neighbors, and you can check your answer with what's up on the board. One small note, when you're drawing the line goes forever. It's really tempting to just connect the first point and the last point, but this line goes forever in both directions. I'm not so picky that I need to see arrows in both directions, but I don't want to see it definitively stop at either of these endpoints, okay? So there's our line, and then finally part D, which quadrants does the line pass through? Okay, so what's our answer to which quadrants? 1, and then 2, and then 3. Yeah, so you can label these just in case you've forgotten Roman numerals. That's how they look. Then it doesn't go through quadrant 4. Any questions on this example? So just trying to shake off maybe some rust and bring us back to some stuff that I think should be familiar. Let's go to the next page, which looks a whole lot more intimidating than the first page. Okay, moving on to 4, our next reader is going to be Alice. Could you read number 4, please? It's on the back of that page right there. Yes. Mm-hmm. Okay, so this is all written out. You're actually not going to really write much of anything, and we're not going to look at it all that closely. You can refer to it later on because all the steps are written out in English on the left, and then the math happens on the right. So here's our starting equation at the top, and one thing that many of you I'm sure have seen before, is this idea of distributing multiplication when it's outside of an addition or a subtraction, right? And so you can distribute that 5/3, and we see the 5/3 x here. This 325/3, where did that come from? Yeah, that's multiplying the 5/3 and the 65, or just the 5 and 65, which is the 325 on top. Okay, and then I notice that there's x's on both sides, which isn't so great. So we're going to move all the x's over to one side. So for example, if I wanted to move this guy to the left, what would I do to both sides? I would subtract the 5/3 x from both sides, and you can see that's what's happened right here. Everything else is copied. Don't get lost in the details. We're just kind of looking generally here. And then looking at this, well, that's kind of intimidating to me, but I'm going to change it to something that is far less intimidating. What if I saw this problem? 7x minus 4x. What does that equal to? That's 3x. Right? We all know we just subtract those numbers in front of the x's. Okay, well, this guy right here looks an awful lot like 7x minus 3x. It's just different numbers, right? It's not a 7, it's a 1/2. And it's not a 4, it's a 5/3. But whatever we did with the 7 and the 4, we just do the same thing with the fractions. So what did we do with the 7 and 4? We subtracted them. So what are we going to do with the 1/2 minus 5? Well, 1/2 and 5/3 is we're going to subtract them. We're not going to do this now, but I'm assuming you guys know how to build the lowest common denominator and subtract two fractions. According to what I've got here, the answer is -7/6. I'm just copying that. I didn't do the arithmetic here, but I'm trusting that you guys can do that later. And then finally, I've got my x right here, and I'm trying to move this -7/6 to the other side. You guys know this technique of multiplying by the reciprocal? So we're going to multiply both sides by -6/7. And that's going to have the effect of getting rid of that -7/6. And then that gives me one more thing with fraction arithmetic to do, and that's multiplying those two fractions together, which gives me 650/7. Not the easiest problem to see, especially not on the first day of a math class. But there's a better way. And so I wanted to kind of go through the more painful way to encourage you to think about maybe this alternative. The very first thing we did before was distribute that 5/3. Well, that's fine. It's legal. It'll get us to the right answer, but it's not required. So here's an alternative. How about we say, well, I don't like the fact that there are fractions in that equation. That's what made the process above so complicated. It wasn't the algebra, it was the fraction arithmetic. So I see two denominators here. I see a 2 and a 3. If I multiply both sides by 6, those denominators will all disappear. Agree? Multiply both sides by 6. Because 2 goes into 6, the 2 will disappear. And because 3 goes into 6, the 3 will disappear. And so all I've done here is I've written times 6 on both sides. Everything else is copied. And when I reduce here, 6 and 2 cross off and become, that's a 6 over a 2, 3. So the left-hand side just becomes 3x. Ooh, much better. And on the right-hand side, this 6 and the 3 cross off and become 2. And so the left-hand side is just 2 times the 5 that was already there. And so the left was the 3x. 2 times 5 becomes 10. And this problem is a whole lot simpler now because we don't have any messy fractions to deal with. Okay, we're not going to look at any more of this problem at the moment. All the details are there. You can try it later on. What I'm interested in having you do more than just watching math or reading math is doing math, like I said before. So on the very next page is the beginning of the activities. What you're going to do is work with your neighbors. If you can't do something, ask your neighbors. If nobody at your table knows how to do something, raise a flag. I will come over and help if I can.